So where we are changing from an increasing to a decreasing function, we call that a critical point. So this point, this maximum value, this minimum value, we call them critical points. Okay, critical point. Example 1. Given f of x is equal to negative x cubed minus 3x squared minus 5, determine the value or values of x for which the function is increasing or decreasing. So now I want to find out where we're increasing and where we're decreasing. What do you think I'm going to do? What do you think?
Find the derivative.
Yeah, good. We're going to find the derivative. Why? What does the derivative tell me?
It tells us when it's increasing or decreasing, when it's above 0 or below.
Okay, so it's going to give us what are called our critical points. And then we know that if I have a critical point, to the left it should be either increasing or decreasing, and to the right it should be the opposite, right? So you're changing from increasing to decreasing or from decreasing to increasing. So yeah, so we're going to find our critical points by finding the first derivative. And then I set that first derivative equal to 0, and I solve. So how do we solve here? We factor. So I can take out a negative 3x, and I'm left with negative 3x times x plus 2. This is telling me now that I have two potential critical points. We don't know if they're critical points yet, but we have two potential critical points, okay, or two potential maxes or mins, okay? So these are our critical points. Whether or not they're maxes or mins is yet to be determined. Okay. So that means that at x equals negative 2 and x equals 0, f of x is changing from increasing to decreasing or vice versa. So how are we going to check it? I'm going to use an interval table. So using an interval chart, I can see what's going on. And remember, guys, with your interval table, the values at the top are always in order from smallest to bigger. Just the way that you do your graph, right? From left to right. Think of the numbers. And then what I want are my factors. Because I want to find out what's happening to the left and to the right of this critical point. So those are my factors. And we want to know if the slopes are positive or negative, right? So I'm setting F prime of x. Okay, so to the left of negative 2, are we negative or are we positive? What do you guys think?
Positive.
Thank you. Good. We're positive. And for x plus 2 to the left, are we positive or are we negative?
Negative.
Negative.
We're negative. Good. So overall, the slope is negative. So therefore, to the left of negative 2, we have a decreasing slope. Right? So it's decreasing. It's like that. The slope of the tangent will be negative. Okay, between -2 and 0. So I don't know, we could use 1. When you sub it in, negative or positive?
They're both negative.
-1.
Oh
Yeah,
no.
Negative
First one positive. Oh,
gonna be positive. And here? And
Positive.
positive.
Okay, so now I have a positive slope. So we can see that we are decreasing when x is less than -2, but between -2 and 0, we are increasing. And then we want to check to the right of 0, so now we can use 1, and so I have negative, positive, negative, and here we're decreasing. Okay? So we conclude therefore, f of x is increasing when x is between -2 and 0, but it's decreasing everywhere else. So when x is less than -2, and when x is greater. Are there any questions? Okay. Next. Given f of x equals x over x squared plus 1, determine the values of x for which the function is increasing or decreasing. So again, to find out where it's increasing or decreasing, we find our critical point. How do you find your critical points? You take the first derivative and you set it equal to 0. Who wants to do the first derivative for me? Who wants to do the first derivative?
X squared plus 2
Good, bottom. Yeah.
minus x times 2x.
Okay, good. Bottom times derivative of the top minus the top times derivative of the bottom. Keep going.
Over 2x squared plus 1 all squared.
Careful.
X squared. Yeah, oh yeah, sorry.
Yeah, it's okay. X squared plus 1 all squared. Good. Excellent. Good. From here, we're going to simplify. So I have x squared plus 1 minus 2x squared. You'll notice we have some of the terms there. And so I'm left with 1 minus x squared all over x squared plus 1 all squared. What can I do to that numerator? Can it be factored? Okay, good. So the proper way to do this would be to factor out the negative and to find the difference of squares. Yes, 100%. Now, because the whole reason we're doing this is to find increasing and decreasing intervals, it's not just too simplified. It's actually okay if you leave it as a difference of squares this way, which would be 1 minus x, 1 plus x, or you could factor out that negative. Of course, we know that is always properly simplified. Okay? Okay. So now what? So now what? This is my slope function. You found the slope function. So now what? Yeah, good. We're going to set it equal to 0. Now, when you have a rational function like this, we know that it doesn't matter what the denominator is, right? As long as the denominator is not 0, which it never will be, right? It can never be 0. We just care about the numerator. What's going to make that numerator 0? So we're going to look at just the numerator. And what are my values? What are my two values here? When x is equal to? Good, plus or minus 1. So 1 and negative 1. Perfect. I've got two critical points. Good. Because this denominator is never 0, we don't have any breaks in this function, correct? There's no vertical asymptote there. Okay, good. All right, so now I'm going to do my interval chart. -1 and 1 are the two x values, and I have 1 minus x and 1 plus x. And we want to know when the first derivative is positive and when it's negative. Okay, so for the first one, positive or negative? Positive, good, nice and loud, positive. What about here? Negative, good. So overall, we're negative. So what do we conclude? It's a decreasing function. All right, next. What about next? Think about 0. 0 is between -1 and 1. So what's happening here? Positive and positive. So the overall result is positive. We have an increase in function. And now when x is greater than 1, so you can think about 2, what do we notice? Good. And then? Good. And so again, we're decreasing. So for my intervals here, I'm increasing between -1 and 1, but everywhere else, I'm decreasing. And to look at this function, just to get an idea of what it looks like, there it is. And you can see that it's decreasing up to -1. You have a critical point there at -1.5. Then it's increasing up to 1. You've got a critical point there at 1.5. And then it's decreasing again. Okay? So in this case, these critical points were in fact the maximum. Yeah? But that's not always the case.
Is there any way to say, not just of like graph, is there any way to say these critical points are actually the maximum?
Yes, you can actually tell already from what we've done. So because the slope is changing, you know that this is a minimum, it's going from decreasing to increasing, and you know that this is a maximum because it's going from increasing to decreasing. If this was going decreasing, there's no maximum. It has to change. In order for there to be a maximum, then you have to have a changing slope, right? So the slope that changes from negative to positive or positive. Good.
Miss, when would a critical point not be a maximum?
So for example, if the, like you're saying, what type of function, for example, y equals x cubed. So you see how you change, like if you look at y, can you picture y equals x cubed?
Yeah.
Okay, let's just say y equals x cubed. Here, you would have always an increasing function. This function is always increasing. But if you set your first derivative equal to 0, it will be 0. And the reason for that is it is still a critical point. It's just not a max or a min. It's a different type of point, and we're going to talk about that later. This has to do with the changing in concavity. You see how the concavity changes here? So that critical point is actually not a max or a min. It's an inflection point. We're going to get there eventually.
Okay, thanks.
Yeah, no problem. Okay, so given the graph of f prime at x, sketch a possible graph of f at x. So guys, keep in mind, we're given the derivative. We're given the derivative. If the derivative is a parabola, then the original function has to be what? A cubic. Good. It has to be 1 degree higher. So we know that it's a cubic. Good. Here, what information, I don't want to give you the answer. What information does this graph give us? How can I analyze this function to help me figure out what my original looks like? Good. Where are your first? Okay. So where your first derivative is equal to 0, and you know you have a max or a min, correct? Or a critical point. That's these two values right here. Where your first derivative is positive, what's happening to the function? If your first derivative is positive, then the function is increasing.
Increasing.
This is where it's positive. So by looking at this, I know that I have an increasing function between -6 and 4. You see that? So if I were to draw a graph between -6 and 4, I need an increasing function. Greater than 4, I need a decreasing function. Less than -6, I need a decreasing function. So how does this work? So it doesn't matter. We don't know. They just want a possible graph. I don't want the exact. So where my y values are, I don't know. And we don't care. So we just want a possible sketch. So up to 6, all I know is that I have to be decreasing. So I don't know. I could put my y value there. And my function is decreasing. Between -6 and 4, I need to be increasing. So I don't know. I'll just put my maximum value there. And then after 4, I need to be decreasing again. There's a possible graph for this problem. Is it the exact one? Absolutely not. But it's a possible graph. Okay? So here, we'll make a note. I hope you guys understand my shorthand. F prime of x is greater than 0, therefore f of x is increasing, whereas at the red point, f of x is less than 0, or sorry, f prime of x is less than 0, therefore f of x is decreasing.
Miss, should the second point be 1 unit to the right?
Did I get, am I off? Let me check. I wanted to. There we go. Thank you. There you go. Okay, perfect. Oh, sorry, I was supposed to draw it over here. Okay, I do it on the thing wrong. Let me zoom down. Actually, I'll do it again. So I've got 6, and -6, -5, and then I have 4, 4. And here we go. Well, and there's a possible solution. Again, is it the exact one? No, but it's a possible one. This shows me that you understand the concept, right? Good. And this is your homework for this section. Page 169, 1, 3, 5 to 12. So really, guys, not a lot of learning here, not a lot of concepts learned. We're basically talking about where your first derivative is greater than 0, or it's less than 0. We know that f prime of x at 0 is now a critical point. Then we call it a critical point. Okay? Find out what's happening to the left and to the right of that critical point. You'll know how your function is doing. Okay? Okay. Critical point. max and min. So we've already sort of talked about this a little bit. If you have f prime of c equal to 0, then that c value is a critical point. Okay? F prime of c is 0, that c value is called a critical point. If f prime of x changes sign from positive to negative at c, then f of x has a local maximum. So we're going from positive to negative. And you can see the shape of it even, right? You can see that it's going to be a maximum. Okay, good. So, positive. Okay. If f prime of x changes from negative to positive, then you can see that it's a minimum. And again, you can see the shape, right? So now what we did before not only tells us increasing, decreasing, but it's also going to confirm whether or not our critical point is a maximum minimum. Because you need to know that. If you're going to be eventually drawing these graphs, you need all this information. You need to know where it's increasing, decreasing. You need to know where all the critical points are. You need to know what the critical points are. Are they in fact maximum? Are they something else? Okay. Example 1. Graph using intercepts and local extrema. What are local extrema? Max or min values. Intercept. What am I talking about? When I say intercept, what am I talking about? Y and x. Good. So where the graph crosses the x-axis and where it crosses the y-axis. Good. And you guys know, how do you find a y and an x-intercept or an x and a y-intercept? Okay, so let's start with an x-intercept. How do you find an x-intercept? Good. You let y equal 0. So here I have 0 equals x to the 4 minus 8x squared. So for me now to solve for x, what should I do? Yeah, good. We always factor, right? So what can I factor out, Logan? Good. And then I have okay? And then from here, what is this concluding? Good. You guys are not used to doing this, but in university you will. So with a different squares, you can say that this is x minus the square root of 8 and x plus the square root of 8. And yes, absolutely right. You can simplify this because 8 is 4 times 2. So it's 2 2. Very good. So now this is showing me that x equals 0 and that x equals plus or minus root 8. So what's important here is we have 3 points on our graph. Just by finding one intercept, I found 3 points on my graph. I found 0, 0. I found root 8, 0. And I found negative root 8, 0. I'm just going to shrink this. So already we know 3 points on our graph. Okay, so now I want to find the y-intercept. So to find the y-intercept, we know that that always happens when x is equal to 0. Very good. And so now I have, where is my function? Y equals 0 to the 4 minus 8 times 0 squared. And we can see it's 0. So we just got the same point again. This happens very often. So it's giving me 0, 0. Well, I already have it. Okay. So here are points on my graph. Next, what am I going to do? Good. How do I find max or min? Good. Now, do we know what their maxes or mins yet? No, so we're gonna call them critical points. So step 2, find your critical points. So it's my first derivative equal to 0. And in order for me to solve, as always, I must factor. So what's factorable here? Good. And then I'm left with? Yeah, good. There's a difference of square there. Okay, so quite a few critical points here. So my critical points. So my potential maxes or mins, I should say, are at x equals 0, -2, and 2. So what you can do at this point is sub these values in to get your y value. So now you're going to have 3 more points on your graph. Clearly, one of them is repeated. Yes, you see that? We already know what f of 0 is. It's 0, 0. Okay? So you sub in these values. To get your point. So when you sub in -2, what do you get? Sub it into the original, right? We're finding points on our graph. So what do you get? I should do it the other way, following here. All right, and so on. Good. For f at 2, it's -16. And f at -2, it's also negative. So now I want to find my increasing, decreasing intervals. So I want to basically find out whether or not these are maxes or mins. Okay, so what do I do? To find my increasing, decreasing intervals, what do I do? Yep, interval chart. What goes at the top, Logan? Okay, good, the critical point. And always in order from left to right. Then we write all our factors. And we're checking the first derivative, whether it's positive or whether it's negative. Okay, so do the chart and tell me what the results are. Good. And that means overall, so we've got a decreasing function. What about between -2 and 0? And which means overall it's positive. And between 0 and 2. And when we're greater than 2. What can I conclude here? Are these critical points maxes or mins? Yeah, good. So which ones, what are they? What do I have? You guys tell me. What do I have? Take a look. What do we have? So here at 0, here I have what? Here I have a max. And here I have a min. And here I have a min. You guys see that? Good. So, therefore, minimum at -2, comma, -16, and 2, -16, maximum at 0, 0. Okay, so let's draw this. So I'm going to put in all my intercepts. All my intercepts. So in order for me to graph all my intercepts, we have a root 8 here. So we're going to need to know what that decimal is. So can you guys tell me approximately what's the decimal for root 8 and negative root 8?
2.8.
Yep. Excellent. Okay. Then I have a minimum at -2, -16. And at 2. I'm good, I'm good. Okay. So,
It's
I
on the
know that-
left. It's you put -1.8.
I did, thank you. There we go. And here, I'm good. All right, so. There's a graph. So the rule is, guys, I think I told you this before. If you're going right to the end of your graph, you don't need arrows. So for example, I'm going right to the end, I don't need arrows. You won't lose marks if you have no arrows. I went right to the end. But if I stop short, you need arrows. Another rule in terms of losing marks. If you extend your graph, and you should, like I would probably extend that further up. I would, I definitely would. So if you extend, make sure that you're accurate. Okay? So make sure that your graph is accurate. You're not just picking some random values and making this graph go crazy where it's not. And the way that you can do that is by checking that value. Right? So if you're extending, in this case it's a little extension, so it's not necessary. But you're going to see some graphs it's a bigger extension. And so you want to make sure that your graph is accurate. Okay? And you can always put arrows just to be safe, and you'll never lose marks. Okay? Okay, let's see how close we got to the actual graph. What do you guys think? Did we do well? That's pretty good, eh? So as we start to gather more and more information, these graphs are going to get more and more exact. Okay? So as I teach you all the steps to curve sketching, these are going to become almost identical to the graphing. You're going to get that. Yes. Using all the steps to get the graph. We're doing it in stages. Yes.
Well, we have lots of stuff.
Yes. Of course, this is all the graphing. Not all graphing questions, but yeah, you are going to have graphing questions for sure. All right. Are there any questions so far? Okay, we're going to do another one. So what's step 1? You got it. So for the x-intercept, I let y equal 0. And what can I do right off the bat? Yeah, we can factor it. What can I take out? Just that? How many x's? Now, unfortunately, you need to use the quadratic formula to find this. This is not factorable, so you're going to have to use the quadratic formula to solve it. So go ahead quickly, do the quadratic formula, and tell me what the root is. I already can see that x equals 0, so I have 1 point. Let's see if there's any others. So do we have any real roots? And if so, what are they? If you guys remember a quick way to check reverse? Yeah, what's it called? Good girl, what's it called?
Discriminant?
Yeah, good. If you find the discriminant, it's a quick way to test whether or not you should do the quadratic formula, right? Because if it's negative, right away you know there's no real roots. In this case, were there any real roots?
No.
No. There's no real roots. So we only got 1 point this time out of the x-intercept. What do you think is going to happen when I go find my y-intercept? Automatically, if I found 0, 0, what's going to happen when I go to find my y-intercept?
0,
Yeah,
0.
so we know at least 0, 0 is going to come out again, right? But let's see if anything else comes out. No. Okay, and this happens often. This happens often. All right. Step 2. I'm sorry, I said let's do it to see if anything else comes out. Could anything else come out? No. Right? Then it wouldn't be a function. Right? For one value of x, we only have one value of y. Okay, number 2. What do I do next? So I found some intercepts. Now I need to find what? Good. I want, yeah, critical point. I want to know if I have any masses or min. So we're going to find some critical points. But we don't know that they're necessarily masses or min, so we're going to test it. Okay, so doing the derivative here. Who feels it's in the derivative? It's an easy one. Yeah. Yep. Okay, so there's your derivative. Now I need to set it equal to 0. And so I need to, factor. Always. Factor, factor, factor. So I can take out a 4x, and that leaves me with x squared minus 2x plus 1. Is that factorable?
Yeah.
Yep, it's a perfect square trinomial, isn't it? So from here, I see that I have critical points at x equals 0 and x equals 1. So now I'm going to find out the y value. Well, I already know f at 0. It's 0. F at 1. What do you get? 3 minus 8 over 3. So 9 over 3 minus 8 over 3. Okay, so my points, I have something happening here. I just don't know whether they're maxes or mins, but something's happening here. These are my critical points. Next, we want to find out whether they're maxes or mins. So we're going to check for increasing, decreasing. And to do that, we use a chart. Okay, go ahead and tell me where my slopes are positive and where they're negative. Good. We know that this is always positive. You know that because it's squared. Good. So we know it's always going to be positive. And here we've got negative, positive, positive. All right, so look what's happening here. Decreasing function, increasing function. Oh, the function's still increasing. Do I have maxes or mins? I have a min, good. Where is it, Jocelyn? Good. So my 0, 0 was a minimum. Do I have any maximum? No. So look, this is going positive, positive. Therefore, there's no maximum in there. Something else is happening there. You're going to learn later what that's called. So here, let's make a note. No max or so therefore, minimum at 0, 0. Let's plug in all the points we know, which are not really that many. I know 0, 0. And what was the other one? 1 comma a third. About there. And so now I have to follow my intervals. So I know that there's a minimum here. And so it has to go like this. But then it continues increasing. Now I want you to notice something, and I don't know if I did a very good job, but concavity is changing here, and we're going to talk about that later. So there is something going on here. It's just not a maximum, and that's why it came out as critical. That would be you're thinking about when you're drawing a polynomial and the zeros, right? If it has an order of 2, it has to, right? All right, and that's your graph. So what do you think? Were we pretty accurate? Not bad. Yeah, not bad. Not great, but not bad. Okay?
Miss, in
Yeah.
chapter 3, would we ever run into a situation where it's like the derivative is 0, but it's not a max or a min?
In chapter 3 or chapter 4?
Chapter 3.
Chapter 3? You're not doing any curve sketching in chapter 3.
And all, but we set the derivatives to 0 to find the max or min.
Oh, yeah, it could happen. No, it's not going to happen. It's not going to happen because you haven't learned how to check yet. So no, it's
Okay.
not going to happen.
Okay, thank you.
You're welcome. It does, yeah. Okay. So, FYI, higher level calculus curve sketching. Critical points may also occur when your derivative is undefined. So do you guys remember when we talked about the absolute value function or cost? And we learned that the derivative is not defined there. It's just an FYI. Critical points may occur there, but you're not going to be responsible for that. That will not be in your lecture. Just so that you guys know. Okay, example 2. Find the critical points for the following function. Now please notice it didn't ask for a max or a min. It just asked for critical points. So that's all you need to find. How do I find critical points? Who's going to do it for me? Sure. Careful. So this would be 2 over 3 minus. Yeah. Yeah. Okay, good. And then we have to set this equal to 0. So to set this equal to 0 and solve, we're going to do this. Now, from here, I set it equal to 0. What do we notice about this function? What do we notice about this function? Are there any critical points? Can you find any critical points here?
No.
Not really, because you have here 0 equals 2. Well, 0 does not equal 2, and it never will. There's nothing I can ever do to make it equal to 2. However, what you should notice is that there is a point where this function is undefined. And this function is undefined when? When x is equal to?
5.
Yeah. It's undefined when x is equal to 5. Does that mean that I have a vertical asymptote there? In this case, what do you guys think? No, I don't. Does anyone know what this might be? I kind of talked to you guys a little bit about it. What would this be? What do you guys think? Not a hole, because, good guess, but not a hole because we're not canceling anything out. Nothing to worry about. So there is, yeah, good. There is a change going on here. What this is and what gives it away is the fact that the exponent is 1/3. This is a cusp. It looks like that. So what you're going to notice is there is something going on here. There is a critical point here, but I can't solve it. Why? Because the derivative is undefined. Okay, but there is a critical point there. How do I know there's a critical point? Because this function is going from concave down here. You see how it's a decreasing function, and then it goes to an increasing. Okay, so we do have a critical point here, but it's unfortunately the first derivative. Again, you will not be given anything else. This is just one way you guys can. Okay? Cool? Yes. You want the y value of the cusp? Is that what you're asking? You want to find the y value of the cusp. Yeah, just sub in here. It's at 0. Critical point, yeah. Undefined critical point. Not always, no, not all the time. Because it could be even your absolute value, so you're not going to be tested on it. It's just random. It could be an absolute value function, we saw that, right? There's many different functions that have critical points that are where the first derivative is undefined. Wherever you have a vertical tangent, right? Remember guys, we talked about that? Okay, so this is your homework. Note, 3B and C answer is incorrect in book. Max and min are interchanged. So what they call a max is really as the min. And whatever is the min, they say the min is wrong. It's the max. Oh, that reminds me. Oh, yay! Okay, let's see. I think I have one. Message in the chat. Are there any questions?
I have a question.
Yeah, what's your question?
Yeah, so for example 2, you said that, so there are critical points, but you just can't find it?
Yeah, hold on. This one here?
Yeah.
You got it. So what I'm trying to show you here is, this is showing that there's no critical points. That's what this is showing, yes? But by further analysis, you realize that there is a point where this derivative is undefined at x equals 5, and so there actually is a critical point there at the cusp.
Right, okay.
Yeah, but you're not going to be tested on that.
Oh, okay.
An FYI.
Okay, thank you.
No problem.